We are the Group 2 and we're here to present and demonstrate to you the Arduino Project 4, the fading light. Before we start, here are the Group 2 members. Josh Valerie D. Paraguna, who assigned to introduction. Members, John Cedric Lahato, who will explain the procedure and instruction of the Arduino. Third, Ashik Yumed Al-Sinawi. He will explain to us our source code to run this Arduino project. And Christian Balwardo. He will the one who tell us our materials that are we gonna use and need for this project. What is the fading light in Arduino? Fading light in Arduino refers to gradually increasing or decreasing the brightness of an LED, and it rapidly switches the LED on and off at different intervals to simulate different brightness levels.
Here are the materials that we are going to use for this project. First is the Arduino board. Acts as the microcontroller to control the flow of current and provide power to the LED. Next is the mini breadboard, a platform used to build and test the circuit without soldering it. Next is two jumper cables used to connect different components on the breadboard or between the Arduino board and the breadboard, allowing current to flow through the circuit. Next is 220R resistor. It limits the current flowing through the LED to prevent it from burning out. And lastly, one green 5mm LED, the light emitting diode that glows when electricity flows through it.
Good day everyone. In this video, I'll talk about the instructions of how to assemble the AP4. The image that you see shows an Arduino shield or a prototyping board with an LED connected using a 220R resistor. So I'll explain step by step of how to break down the circuit. The components in the image is DF robot shield or a prototyping board, green LED, 220R resistor, and the jumper wires. First step, we go to LED placement. The green LED is placed on the board. The LED has two legs. The longer leg is a positive terminal and the shorter leg is a negative terminal. The longer LED is connected to the 9th pin on the shield using a green jumper wire. The shorter leg is connected to the ground using a black jumper wire. Next step is resistor placement. A 220R resistor is placed between the 9th pin and the anode of the LED. This resistor is used to limit the current flowing through the LED, ensuring it doesn't burn out. Number 3, Step 3, connections to the board. One end of the resistor is connected to the 9th digital output pin of the board, and the other end is connected to the anode of the LED. The cathode of the LED is connected to the GND on the board. We proceed to our procedure.
Hi everyone, in this video, I'm going to explain you how our fading LED code works in Arduino. So this code, we declare a variable LED pin and set it to pin 10. This pin will be connected to the LED and it will control the brightness. In the setup function, we use pin 10 as an output using pin mode. This enables the pin to send a signal to the LED, which let us adjust its brightness. The loop function is where the fading effect happens. We have two custom functions here, fade on and fade off. So let's break them down. This function makes the LED gradually fade on by increasing its brightness. For byte value equal 0, value less than 255, value plus equal increment. This loop starts a value equal to 0 equivalent to LED off and increase by increment until it reaches 255 or to full brightness. When we use the command analog write LED pin value, it helps us to tell the LED how bright to shine. The LED can be bright or dim depending on the number we give it. The command delay 350 by 5 makes the program wait a little bit before changing the brightness again. This waiting time helps the fade in and out smoothly. If we make the wait time shorter, the LED fades faster. This function is very similar to fade on, but it works in reverse to fade the LED off. For byte value 255 value greater than 0 value decrement. This loop starts at a full brightness 255 and decrease by decrement until the LED is off or 0. Analog write LED pin value. Again, this adjusts the brightness using PWM, gradually reducing the LED brightness. Delaying 250 by 5. This delay gives the LED the time to fade off and you can tweak it to control the speed of the fade. In other words, in the setup, we set up the LED on pin 10 as an output. In the loop function, we use two functions, fade on and fade off, to gradually turn the LED on and off by adjusting its brightness with function PWM. The LED fades on over 5 seconds with the smooth increment, then fades off over 3 seconds. That's it.